Welcome to you all, few people still barging in, welcome. Please find a seat. So my name is Hanno Embregts. I work at Info Support as an IT consultant. I've been a Java developer for almost 15 years, so I know backend, right? But I think whether we work in backend or in front end, when it comes to version control, we all need it. So I think it will still be interesting to spend some time together. Quick show of hands. Who of you is currently using Git? I should have rephrased this question. Is there someone in the room who doesn't currently use Git, but something else? Okay, you come to the right talk then. Yeah. I always have the final question, who doesn't like these stupid hand-raising questions? So, oh, okay, yeah, fair enough. I also don't like them. So I've been a developer for almost 15 years, but when I started out studying computer science, we didn't really use version control. I'm not sure what you folks used when you were in college, but we used version control by email. Yeah, you know that one, so just zip up your files, send it by email, and try to merge the conflicts along the way. It was dreadful. So when I finally started my first job as a Java developer, which was in the year 2007, grandpa talking, right? I was really eager to learn the best the industry had to offer on version control. So I went to my new employer and I said, please enlighten me. What do you do to solve this version control by email thing? And they actually did, this is what they did. I kid you not. So version control by USB stick, right? So you had a copy of the code on your USB stick, plugged it into your computer, did a few changes, and we had a central point in our open office space. There was a single computer, and it was called the integration laptop. You went over to your integration laptop, stuck the USB stick in, merged it in some kind of magical way, and then, returned to your desk and worked on another change. Actually, this was a single point of failure, of course, this integration laptop, and we actually had, in our Exchange system, we had a resource that was named after the integration laptop, and you had to book slots of time to be able to merge your code. So that was kind of disappointing, because I really was eager to learn about version control. Fast forward 15 years later, so right now, I've gained some experience with real version control systems, like Subversion and Git. And besides doing consultancy work, I also teach a few courses at Info Support. From time to time, they address basic software development topics, object orientation, automated testing, continuous delivery, containerization, such things. And one of the courses is called Git for Developers. It's a one-day course, and I teach the students how to use Git as a developer. So pros and cons of distributed version control systems, how they compare to the old ones, CVS, Subversion, using the command line, that kind of stuff. And this is actually one of the course slides. And it displays which version control systems have emerged until now and when they became available. It also tries to put the publication date of the version control system in perspective by comparing them to the most modern phone known at the time. Right here. So, for example, the Nokia 3310, I had one of those. Who had one of those? Yeah, welcome to the club. Relates to Subversion, both indestructible. And CVS, who has actually used CVS? Yeah, welcome to the club again. I used CVS at the company where they decided to get rid of version control by USB stick, and they chose CVS. Okay, but still, CVS, published in 1990, it relates to this thing with the power block here. Both are obviously ancient. Now, when I talk about this slide during the Git course I mentioned, I tend to focus on the year 2005 because a lot of new version control systems, products emerged during that year. 5 new version control systems, in fact. Does anyone happen to know why so many new systems emerged in that year? Did something happen in that year? Well, the answer is actually hidden in the slide, because BitKeeper published in 2003, was the only distributed version control system known at the time. And Linus Torvalds, who was working on the Linux kernel, used Bitkeeper together with his team of course, they were all remote, right? Remotely working on this open source Linux kernel, and they used Bitkeeper. And they had kind of a special agreement with Bitkeeper because it was a commercial product, but open source projects could use Bitkeeper for free. And in 2005, Bitkeeper said, no can do, open source project also need to pay until from now on. The entire open source world was not amused, and Mr. Linus Torvalds in front of them. So what do you do when the only distributed version control system is no longer freely available? You create a new one, of course. And lots of people came up with that idea. So Git was created because of this. I know for a fact that Mercurial was created because of this. And as you can see, a few others also during that time. Now, at the end of one particular course day, when I was giving this course, one of the students that I had taught came up to me and said, that's all nice and dandy, the year 2005, but I think the period that happened after that is far more interesting. I mean, what has happened here? It seems like nothing has happened at all. What's going to be the next big thing? Or she asked this with a bit of a snicker, a bit of a laugh, or is Git going to be around forever? And I said, well, it seems like it is, but of course in software nothing sticks around forever. So it was a very good question, and I didn't have any answer for her, other than Git will be around for a while, I guess. And I really hated the fact that I couldn't provide an answer, so I researched it for a bit, and it got slightly out of hand, and now you're attending a conference talk about it. So that's how these things go. So thanks for attending, you're most welcome, and let's just try to find the answer to this student's question together, shall we? And at the end, we'll be able to answer it. Now, whenever I hear somebody say that something will probably be around forever, it reminds me of this guy. And, this quote is actually disputed. We don't know for sure that he actually said it. He probably added for now. And I think that he might have added for now because Mr. Gates also knows very well that in the computer industry, change is the only constant. This idea has been valid in our industry for as long as I can remember, because requirements change, priorities change, dependencies change, and you folks should know this better than I do, browser behaviors change. They all change, so change is the only constant, which means that Git will not be around forever, maybe for now, but eventually there will be a successor, a version control system that will be more popular than Git. And if we want to answer this question together, we should probably look at why Git became so popular in the first place. Well, just to refresh your memory, these are Git's main features, but you will all know this because you just admitted to using Git. Distributed, free and open source, fast, optimized for branching. So Linus Torvalds himself said everything you do on a daily basis should take less than a second. And this is why fast is one of the features of Git. For example, fast branching. So if you remember the days of CVS, like I did, developers in the CVS age were afraid of branching because it took such a long time, because creating a branch in CVS is effectively copying an entire folder with all its subfolders and all the tiny files that were in there, so that could take quite a lot of time. And Linus Torvalds also said, when I'm trying to decide on a certain feature of Git, I just take CVS and make the exact opposite decision. So kind of, what would CVS not do? The bracelets with what would CVS not do? I'm not sure if he wore any, but that was one of his mantras. Well, when we want to make a prediction, we have to input some variables into this prediction, right? So I think killer features should be one of our prediction variables. And I mean two things when I say that. The first thing, a product that has a new feature that has never been seen before, or a similar feature but implemented differently. A similar feature implemented in a radically different way to distinguish it from its competitors. For example, how Git did this with fast branching, which is very radically different from CVS. And we'll discover a few more of these variables along the way. Okay, so here's some information on how Git became the big thing in the first place. Well, there's a lot of information in this chart. I'll talk you through it. For example, The blue line is Git, and it has been growing ever since, but it started growing more rapidly after GitHub launched. And again, it grew more. It grew at a faster rate when Bitbucket said, "Hey, we support Git from now on." So Bitbucket was one of the main competitors for GitHub, and they actually only supported Mercurial until this point in time. You can actually see this in the Mercurial popularity graph because it started declining here. So Git's popularity was also based on the support by the hosting platforms. Well, all approximations, of course, because there's no real data about version control system usage. Like you can just get information on browser usage, which is very, very simple, but on version control systems, it's very hard. So this data is like an aggregation from Google Trends, GitHub, Atlassian, all kinds of stuff. So this data is also approximation. One thing to note, TFS is a version control system by Microsoft. It's now called TFVC, Team Foundation Version Control. You can still choose it as an option if you create a repository in Azure DevOps server, for example. This is actually taken from Azure DevOps. But Git is also an option, and I think currently most people choose Git here. So I think this should be our second prediction variable. The available source code hosting for a particular version control system has quite some influence on its popularity. And if you think about how Git became popular besides hosting platform support, I think open source community support is also a good one, because Git really did popularize open source development around the globe. Without Git, that would be a bit harder. Prediction variable number 3, open source community support. While we have these three variables, we could try to make a first prediction, which at this early stage can only be done by using the approach extrapolate from incomplete data, like it says on the mug, and there's no number 2. So if we extrapolate from this incomplete data and put the percentages in a table, we get something like this. And I just took the year 2010 as a starting point, where we see that Subversion is the most popular product and Git is still climbing. If we would then add like a second year, for example, 2021, because I have to, the abstract says in 10 years, so I have to eventually get to 2032, right? We see that Git is by far the most popular product, and Subversion has declined rapidly. Mercurial is also declining, but not as fast as Subversion, and TFVC is staying kind of the same, and I can't imagine anyone using CVS anymore. So I didn't put it at 0 because I can't be sure, but like less than 1%. The question is, how will these percentages look in 2032? Well, if we would just continue the trends, I think it would look something like this. So Git on top. Second one would be Mercurial, I think, maybe TFVC for a bit, but I think that will also decline for a bit, actually, and Subversion will be diminished. So Git will stay on top. Thanks for attending my talk. Yeah, you know I was kidding when I said that, right?
Oh, the Chinese constant. That's strange.
Yeah, that's very strange. And also, another strange thing is that we haven't included any new products, which, of course, yeah.
What is holding the Microsoft one stable? Is it like they vendor lock some solutions? Why the prediction is still that it's going to be 7?
That's a very good question. So the data that I had says that TFS is stable until 2016. I don't have any new data beyond that. Like I said, it's very hard to aggregate this data, but it's a good point. It will probably diminish a bit further. Yeah. 7%
of users click the wrong button in VS.
I guess that is it. But it's a fair point. I should probably make sure that it's a bit lower next time.
Yeah, because you got Azure DevOps switch, you didn't include that one.
No, I didn't. Yeah. Okay, fair point. Thank you. Yeah, so let's include some new products, right? Well, including new products is actually exactly what happened during the browser wars, multiple times actually. When I was in college, when I was still doing version control by email, I did a talk on the browser wars. I tried to predict what browser we would use 10 years later in time, and so the talk was actually similar to this one, apart from the fact that my slides looks very different. I've just included one of them. Yeah. So earlier today there was a speaker who apologized for his terrible designs. I apologize for this slide deck design. It's terrible. But this is what everyone was doing back then, right? The background gradients and page numbers. Very cool. Repeating all these headers. Yeah. Maybe slide deck designs are like fashion. If we wait another 15 years, we'll be very hip and trendy again. Anyway, apart from being ugly, the slide shows that the Internet Explorer browser family was very dominant in 2005. 90%, almost 90% if you add these percentages, was using an IE browser. Now, in this college talk, I predicted 3 things, and 2 of them actually happened 10 years later. So you could say I'm kind of experienced with doing this kind of stuff. These were my predictions in 2005. I predicted IE would be surpassed as a top browser family, so all versions. Firefox would surpass IE on its own, and also Firefox would be the top browser. I was kind of a Firefox fanboy back then. Well, just the last one never happened because Firefox never was the most popular browser in the world. But the other 2 happened because at this point in time, the little blue line is a bit higher. The little black line is a bit higher than the blue line. So Firefox was a bit more popular than IE. And also, well, of course, Google Chrome came up and became the most popular browser. Didn't count on that one, but it shows that new products can emerge and take the market by storm. Technically, the last one, if you see the dates, it happened in 2016, so 11 years later, but I hope you'll forgive me for that one, not 10 years later. Still, I was right, sort of. I correctly predicted it. I was fairly confident this would happen eventually because of a mechanism that we call the law of the handicap of a head start. If you're Dutch, de wet van de remmende voorsprong. So this term was coined by a Dutch historian, Jan Romein, in his essay The Dialectic of Progress in 1937. And it suggests that when society dedicates itself to certain standards, for example, tabbed browsing during the browser wars, the individual or the group that starts out ahead has difficulties adjusting to these new standards. This head start is an advantage at first, but it becomes a handicap because other competitors add new features in the mix. The society gets used to these new features, and then it becomes harder to adapt. And well, we have seen that Microsoft responded really late with tab browsing. So this resulted in Firefox and Chrome taking over. So to summarize, just as in sports, it is valid. This is also true of IT. It's a lot harder to stay on top than it is to get there. So here we have our final prediction variable, the handicap of a head start. If you're the dominant product right now, eventually you will be replaced by a new one. And it's important that you keep innovating, like Google Chrome is doing right now, for example. So let's return to the version control world and see which products we're going to investigate. I've selected 2 products to investigate as sparring successors, Fossil and Pijul. These 2 version control systems have been published after 2005. I thought I wouldn't consider any systems before 2005 because, let's face it, it will probably have beaten Git already right now. And seeing as they haven't, I just chose to stay away from the period before 2005. I think in the abstract there was a 3rd version control system called Plastic. I have researched that a bit, but it's a bit of a niche version control system. It focuses primarily on game studios, where contributors work with graphics and other binary files. They have a kind of cool thing going on with image diffing, so that could be cool to make the slides, but it's very niche part of the market, and also it's commercial software, so they haven't heard the BitKeeper story yet, I guess. I really wanted to focus on open source products here. So let's dive into the first one, Fossil. So Fossil is also distributed, just like Git. It has integrated bug tracking, wiki forum, and tech nodes. It has a built-in web interface that you can call up from your local machine, and using the web interface, you can browse your revisions, for example. it has an automatic push after each commit if you configure it like that. So they call this the auto-sync mode, but you can also manually merge just like you are used to in Git. And it can show the descendants of your check-in, which is kind of cool because you can't do that in Git. In Git, a commit only knows the previous one, so its ancestor, but they never know the descendants. You can, of course, you can't really call it up in a UI, that's what I'm saying. And it's not a very fast operation anyway. It also supports operations on multiple repositories. So if you're doing microservices and multiple repositories, it can do like pulls to all repositories at the same time. So that's kind of a neat trick. And it has a preserve all history philosophy. So there's no rebase in Fossil. Also, why would it be called Fossil? A very strange name for a version control system that could rewrite history. So no rewriting any history. Everything stays in the repository. It is written in CN and SQL, and it was even specifically written for the SQLite project. So Fossil was written for the SQLite project to serve as a version control system. And it also offers free code hosting. The app is called Chisel, chiselweb.com. You can host your own repositories there. But actually, because it's just these projects benefit from each other because it just uses an SQLite database to store its revisions. You can simply host it yourself. You just need an SQLite database and a web server. So any hosting provider could do the job. So I already told you in Git, a single commit knows only who its ancestor is. And in Fossil, this is stored in a database file, and it keeps track of both ancestors and descendants. So it's like doubly linked. And when we're talking about Fossil, it's often called GitHub in a box because you can call up this UI and it has all these kind of features: wiki, ticketing, bug tracking, embedded documentation. It's very feature-rich web interface. So actually, this makes Fossil very well suited for small-scale projects, startups, but not really for large-scale open source development like the Linux kernel. But we'll get to that in a minute. Okay, so let's do a quick demo then of Fossil. So here we go. I hope this is all readable also in the back. All okay? Yeah, large enough? Great. So let's create a directory here. Nothing fancy, just creating a directory, right? And when you create a repository in Fossil, the actual repository file is kept outside of the repository. So with Git, we are used to this hidden folder called .git inside of the repository, while with Fossil, it's outside of it. So we create a repo file like this. Now we have a demo.repo file and a demo directory, and we have to link them to each other. And we do that by changing dirs into demo and telling Fossil to open the file demo.repo, and then it gives me some output. It says the repository is here. This is the checkout. The main branch or tag is called trunk, and there's one check-in right now. Well, let's create a file, right? We're going to create a file that eventually will calculate a random number, random.js. Let's add it to the repository. This is very much like Git, actually. It has added random.js. I can ask about the changes if I want. These were the changes, just like Git status. I can create a commit. A change that is here also called a commit. Initial commit. Here we go. So now let's check out our UI, Fossil UI. And it has, we can approach it on port 8080. Ah, there it is, that's opened up already. This is what you get when you call up Fossil UI. So you see here your check-ins, you see a timeline, there's a home page, nothing much on there actually. You can see the files you've added, and there's an admin portion. Well, it's of course not very filled up right now, so let's try to do that. So let's stop the UI again and create a branch. Fossil branch new. Oh, this looks good. Seems like I've done this before. There we go, created a branch. let's put some implementation in this JavaScript file. I'm going to use VI because I hope it will be the fastest way to do it. Not sure if I'm going to regret that one or not, but so let's create a function we call random, and it doesn't take any arguments. Doesn't take any arguments for now. And we have to come up with a random number, of course. Well, I always like the XKCD comic that says choose random numbers by dice roll. So I brought a die. It's flashy also. I'm not sure why my daughter lent it to me. So just throw it. What does it say? 4. Return 4. Chosen by fair dice roll. Guaranteed to be random. If we had more time, I would provide a better implementation, of course, but we're talking about version control systems here. We have to call this function and log something to the console, of course. Like this. I think we're done here. Just to make sure that it actually does anything. Well, it seems like that's working. Okay, so that's great. So let's add it to our commit. There we go. Commit message. Implement random. It's not the best implementation, but it is an implementation. Let's call up the fossil UI again, because I want to show you about the descendants. So here it is again. Actually, that's kind of funny. I created a branch, but I never switched to it. So this is actually committed to trunk. Well, that's not really a problem. But what is interesting is if we open up this initial commit right here, it tells me view the ancestors, which is the initial empty check-in, and also view descendants. And it can tell you I've got 2 descendants right here. So that's kind of neat. I haven't found any good way for Git to do that. Okay, let's return to our slide deck. There we go.
Can I ask a question about the descendants?
Sure.
For a distributed version control system, right? Your node is not necessarily aware of
Yeah.
the node. So the reason Git doesn't keep track of it is because, who knows what someone else has done with.
Yeah, it will only show you what it will know
So
in the local copy.
link, or is it just there for your convenience so that you know what's going on?
Yeah, it's the latter. Yeah. Okay. Thanks for the question. Of course, there are bad things, right? I'm not going to say fossil is the best solution to anything. I've read quite a good blog post about dealing with large files because your repository is a single SQLite database file, and it could get quite large, of course. So if you're interested in that, dealing with large files and a growing repository size, you could check out this link. I'll post the slides on my Twitter profile, by the way, later, so you can read up on that if you would like. Looks like Fossil's garbage collect might not be as sophisticated as the one in Git yet. So if we would put these 2 version control systems to each other and think about what is the right tool for the job, well, the sample project for Git is the Linux kernel, globally developed, worldwide, contributors everywhere, whereas the Fossil team consists of only 4 people. Yeah, small team working closely together, and they have all their UI stuff right there at their local machines. And the engagement is quite personal. Every committer of the Fossil and the SQLite project knows each other personally, whereas with Git, it's global engagement, more than 5,000 contributors, so you don't know them personally, which also leads to something of different workflow. I'm not sure if you folks are familiar with the dictator and lieutenants workflow that the Linux kernel uses, but in fact it comes down to this. Linus Torvalds only trusts a few people that he has assigned some components of the Linux kernel to, his lieutenants. And the lieutenants trust a few other people for subcomponents, and so their workflow is built on hierarchy. Whereas with the Fossil and the SQLite team, the workflow is built on trust. They trust the 3 other developers that they are good at their job. This really makes you think, why are we all using Git, a version control system that was designed to support a globally developed open source product like the Linux kernel? Are all our projects like that? Well, if you're actively working on an open source project, I can understand your choice. But is your product actually like the Linux kernel, or do you work with a small team on a small app? I'm not saying you should switch to Fossil right now, but it is something to think about, I guess. Okay, the second version control system is called Pijul, and before I start to talk about it, we have to talk about the name because it's hard to pronounce. It's a Spanish word, Pijul, and it is a type of bird that is local to Mexico. It's a bird known to do collaborative nest building, so this is why the creators called it Pijul, because they like the collaboration on the nest building that this bird is doing. And actually, the hosting site is also called the Pijul nest, so that's kind of a cute analogy. So Pijul was introduced in 2015, and these are the features that it promises. It is also distributed like Git and like Fossil, but it's based on a theory of patches, so it doesn't work with snapshots like Git is doing. It works with patches. I'll get back to this later. It's not the first patch-oriented version control system that existed. In the popularity graph I showed you earlier, there was a system called Darks. Anyone familiar with Darks? Yeah, a few people. Also patch-based. It never really gained any traction because, well, not mainstream actually, because a lot of operations were very slow in Darks. And Pijul is trying to be like a better version of Darks, trying to fix the performance issues. And it also has a feature called interactive recording. So after adding files to your repository, when you want to commit them to the repository, you can still choose whether you want to push all files to the repository or leave out a few of them, or even leave out a few of the hunks inside the file itself. And whereas with Git, you have to decide this beforehand. When you're going to commit it, you are stuck with the files that you added already. Here are some quick facts about Pijul. It's written in Rust. It's one of the more faster languages because it's a low-level language, so its performance is often compared to that of C++. It's bootstrapped since 2017, which means they use Pijul to version control Pijul, just like, for example, the people at JetBrains use their own IDEs to develop their IDEs. So they eat their own dog food, actually. And like I said, they offer free code hosting at nest.pijul.com. You can create your own Pijul repo there, push to it if you want. So this patch-oriented design, how does it work? Well, a patch is an intuitive atomic unit of work. And it focuses on changes and not on differences between snapshots. And applying or unapplying a patch doesn't change its identity. This is very different from Git. When you create a change in Git, Git stores the end result of your change, snapshots of files. If you ask for git diff, it just takes 2 versions of files, computes the differences when they are needed. And each snapshot has its own identity, its own commit ID, whereas with Pijul, a patch has an identity. This also means that if you apply several patches in succession, the end result is always the same. It doesn't matter what order you applied them in. So this is actually great for cherry picking, because if you say cherry pick this patch, Pijul will know I will need a few dependent patches, and then I can apply the final one. And then the patch application is complete. So you don't need to manually find some commits to include in your cherry pick, because Pijul will do it for you. Like I said, it keeps track of dependent patches. Rebase doesn't exist in Pijul. And merge kind of exists, but also really doesn't, because any merge or any attempt to get 2 lines of code together is actually just applying a few patches. So that's actually the only operation that Pijul has, apply 1 patch or a list or a series of patches. So all merge operations are just like git cherry pick, in effect. It's important to note that conflicts in Pijul always happen between changes. So if a change A conflicts with change B, then in order to resolve those conflicts, you need a third change C. So a third patch will resolve the conflicts in A and B. This also means that when you get to a conflict, you solve it once and for all with a third change. Whereas in Git, conflicts happen between two branches, for example, you have to merge the conflicts into a new commit, another snapshot. But it could be that you would get the conflicts again when you rebase or you merge. Well, I've had this countless of times, had to solve the conflicts over and over again because it's snapshot-based and not patch-based. Let's see an example here. So if we have two files, and the end result of all the changes are these files here, 2-line, 4-line, 4-line. In both examples, they are the same, right? And if we're starting with this one, Git will store this snapshot, 1-line, 2-line, 3-line. And if you change something, apparently we switch the order of the first 2 lines and replace 3 by 4. This is what Git stores, just the content of the file. And after that, we change 1 line into 4 lines, so Git stores this snapshot. So this is the end result. Whereas in Pijul, everything is a patch, so it stores, in the first one, it just stores, I've added these 3 lines, 1 line, 2 line, and 3 line, all additions. In the second one, it says, oh, I've deleted the 1 line at the front, but I've added a 1 line after the 2 line. I've removed 3 line, and 4 line I've added that one. And in this one, it seems like I've removed the 1 line and added the 4 line, and this is the end result. So that's, question.
I guess it must have some diffing algorithm running there between the state that you
Yeah.
in the repo
Yeah.
and you're going to commit, because it has a generated patch, right?
Yeah.
Is that significantly different from Git's diffing algorithms?
It is a bit different because it needs to keep track of dependent patches. So for example, the addition of 1 line here is only possible because 2 line was added in the patch before, because this 1 line very confusing, was added after the 2 lines. So it will internally store that this patch is dependent on that one, and otherwise it can't insert the line below the line before that. So each patch has like a huge graph of dependencies, and it stores it internally. Yeah.
You said, maybe you'll get there still, but so you can swap around these patches and it will still end in the same result. But surely there, in the third one here, you remove 1 line once again, and then if you swap that around with what is now a second patch, where you add 1 line, so it keeps all that in track as well.
Yeah, it does.
Right,
But
so if you want to apply that third one, it will apply the second one as well.
Yeah.
Effectively, yeah.
I'll show this in a demo I have for you. Maybe an analogy works here. What if commits were not commits but bank transactions? This is what would happen. The left is snapshot-based, so Git. The right is patch-based, so Darks or Pijul. If this is my initial balance, Git will store, this is your balance, 100. And Pijul will store, I've added 100 to your balance, resulting probably in a balance of 100. Then I get paid, not much, but I get by, right? Git stores 400 when I get paid 300. Pijul stores, you have added 300 to your balance. I'm not sure what the end result is, but we'll get to it later. Then I'm going to pay my heating bill, which is a massive amount of money these days. Git will store €0. I'm out of money because I've paid my heating bill. Actually, I spent more on heating than I get paid, so go figure. Pijul will just store, I have removed 400 from your balance, but I'm not sure what your final balance is. But you can ask me if you're interested. So this is maybe the analogy works a bit better than the last example. Now for the demo, because I promised to you folks that I will demo Pijul. So let's do that for a bit. Just a quick one, like I did with Fossil, of course. Yeah, here we go. So we're in an empty folder right here. We're going to create a directory, and I think I'm still going to call it demo. So not very much fantasy there, but still. And I really want to start off by forking. Pijul can also support branching of some kind, but the command is called fork. And this is the domain we're handling right now. I want to store which movies I've seen this week and next week. So let's create a channel. A branch is called a channel in Pijul. Let's create a channel For next week, if we ask Pijul what the channels are, there's a main and there's a next week. And let's just create a movies.txt file. The movie I saw last week was Inglourious Bastards. Long time coming. I apologize for seeing it so late, but it was on Netflix, so. I think it was published in 2009. Sounds about right? Any very passionate movie fans in the room? No? I'll just store it like this. We'll record this one, and I'll just say, I watched the movie. Oh, sorry, I have to edit first. Sorry, just like in Git. Add movies. Record -m, watch the movie. Spelling is hard. Oh, I need to, that's nice that does that. I have to create a key for my user. Thank you for the warning. I'm getting a time warning. I think I have to, it's like this. No, it's just the other way around. Passphrase, no passphrase. Okay, let's record it, watch the movie. And now we get like sort of a commit modal. You can enter a message, but I provided -m. So this is the message. This is the author. With an author key means you can change your name later, very inclusive. If I want to change my name to Hanno, for example, I can just do it. This is just my author key. I like that one. And these are the dependencies. This is just the initial patch. But when I go on in my repository, it will become much larger, of course. And this is where I can, this is the interactive commit. So I can just say, I don't want this line. Just put the hash before it, for example. But I want them all in this case, right? Okay, so we've watched the movies. Then when I watch a movie, I also like to drink a beer. So let's add a beers.txt. Well, sorry, it's not here, of course. I have to create it first. Here we go. And the last beer I drank was Jopen Moyenel, which is an IPA, I guess. Any very passionate beer fans in the room? No? Still the only one? Let's add it and record it. Pijul record -m drink a beer. Drink a beer. Here we go.
Can you also skip that interactive thingy?
Yeah, you can if you provide the A here. Oh, sorry. Which means just all. Add everything. So you can. Right? So we drank a beer. Now let's watch another movie, right? vi movies.txt. What was the movie I saw next week? Yeah, what movie was I see next week? Inception. I've watched it like 5 times already. 2014, if my memory serves me correctly. And if not, well, then not. Okay. Add movies, record. Let's try the A then. Watched another movie. There we go. No modal. Okay. We can also come up with a list of files that Pijul is currently tracking. Pijul list, this is the list of files that it's tracking right now. And I want to show you Pijul log, because this is important. What I want to show you is this dependent patch thingy. What I'm going to do is I'm going to switch to the next week channel and try to apply this patch. Watch another movie. Well, in order for that patch to be applied, the movies file needs to be there. So I'm expecting that it will apply this one also. In order to do that, I'm going to copy this and put it in a node or something, so that I can refer to these hashes, these chained hashes. There it is, new node. No embarrassing existing node, that's a relief. Get groceries, right. Call the nagging wife. No. Password, yeah. Didn't prepare this bit, so yeah. Okay, let's change to the channel we created. Channel switch next week. which we created before anything existed, right? Okay, so there we go. I want to make sure that I'm not listing anything. I'm not listing anything, so no files. And let's apply the hash of the another movie patch, which is this one. Watch another movie, right? Oh, it is still here at the top. That's very convenient. Didn't have to use nodes at all. Okay, and then ask the files. We've got the beers also. That's very nice. Not sure why, but when we ask for the log, we see both patches has been applied, whereas I only provided this one. So it knows that it needs this patch to be able to create the file. All very simple, of course, but the basic principle stands even when you're doing a big open source project. So that's how that works. I have to change to the slides again because we're going to wrap this up. And if there Pijul's current status, that's a good one. It has been in a 0.x status for quite some time, but right now they're working on the version 1.0 beta, which means that it will become feature complete and also production ready very soon. It's been in beta for most part of 2022, I guess, so I'm kind of following that to see when they drop the beta. But they are not changing anything on their implementation, so the moment is coming near that you can really use this for your open source project, stable versions. Let's get to the predictions, because that's the one that you've all come here for. These were the variables that were used, and I'm going to score the version control system by these variables. So killer features, I think Pijul has the most promise, because applying patches is a lot more simple than just getting snapshots in your repository, conflicts, head detached, all kinds of stuff. I was talking to another attendee and earlier today, and I recalled a team where I worked where some of my team members were not really technical. They wrote texts for the public website, and they are really struggling with Git, applying all these patches, cherry picks, and they would really botch up their local repository, and we had to do fresh clones. I think with Pijul you will see this less and less. Of course, they will need to add some GUI tools, I guess, but just from the command line, I think it looks promising. Hosting, of course, Git is the clear winner here, because there are 19 different hosting websites for Git, and 9 for Mercurial, only 1 for Pijul, and only 1 for Fossil, so they still need some work, gain some traction in this area. Open source, Git and Mercurial are great. Team Foundation is not so great. Fossil also not, actually, because it's really aimed at small-scale projects. And Pijul has the Pijul Nest, which also hosts a few open source projects already right now, so shows some promise. The handicap of the dominant product, well, Git suffers the most from this, of course, and Mercurial maybe for a bit. If I add all these scores up, I think the best score will hand up to Pijul, and the worst to Team Foundation version control. So to the final predictions, this was my first attempt. This is actually my final attempt. I don't see Pijul taking over in 10 years, actually, because it has to become a bit more popular. And more hosting platforms should emerge. But if they do, then this 5%, my prediction can maybe go a bit higher. And I also think Fossil will be around in 10 years' time, because I quite like that small-scale project thing. If it becomes a bit more famous, then maybe the percentage will grow a bit. But I think Git will still remain on top. And if it comes out with ways to appeal to non-technical people, then I think it could still be popular for a great many years to come. But I'm watching these two to see if they will take over eventually. But I think it won't happen in 10 years. Maybe a bit later, who knows. If you're really into the topic, I've got some links up on the slide. Some links I also read in preparation. I said I will tweet the slides, so you can read up on them later if you want. What should you do right now? Well, actually, I've got a slide that says, now what? If your project is nothing like the Linux kernel, small scale, all the developers, just try Fossil for a change, see if you like it. And the same goes for Pijul. If the snapshotting is too technical for your team, try Pijul and see if it helps you. And maybe it will become a bit more popular in the future. We've done a few questions already throughout the talk, so I'm going to end this for people who want to leave. If you really have some questions, you can come up to me after the talk. I'll be glad to answer them. If you want to reach me, the slides are at the Pijul nest, right? PDF export of the slides, so you can. I will tweet them, but you can also find them there. This is my other information, my website, my Twitter handle. If you like more updates on Java or version control, follow me, and you'll be updated. And thank you for your attention today.